morning, algebra students. It's Miss Myers here. What I would like to do with today's video is complete our learning target 8.1, which is I can solve a linear absolute value function graphically. And by the end of today's video, you should understand how to do that after we go through two problems together. The first problem I'm going to go through is a system of equations that you can find in your homework packets. It's problem number 8 and practice number 4. Okay, so what you'll notice is the first function in our system is an absolute value function, and what we've been doing so far is making a table of values to help us graph this. Feel free to use your graphing calculators to create this table. I'm going to start by identifying my vertex, which is the opposite of C, D. Remember, this is our C value, and this is our D value. So in the middle of my table, I'm going to go ahead and plot -1, -1. Now, what's tricky, and maybe you've noticed, there's a 2/3 in the front. Our A value is 2/3, which is going to give us some decimals. And my little trick to avoid decimals is if I look at my denominator of 3, I can make the X values in my table count by 3s, and I will always get a whole number. Feel free to also look at this in your graphing calculators. So what I could do is, instead of counting by 1s, I'm going to put a 2 and a 5 because they're 3 apart. And in the opposite direction, I'm going to put -4 and -7. Now, if I plug in my X values in my table, or use my calculator and the table function, I should be able to complete a table. If X is 2, Y is 1. If X is 5, Y is 3. And then these values reflect on the other side of the vertex. So I'm going to have the same values here. So let's go ahead and plot this graph. I have a point at -1, -1. That's my vertex. And from here I should get a V shape that faces up. So 2, 1, and 5, 3. Let me work on the other side, -4, 1. And it looks like I'm going to run out of room when I'm trying to plot -7, 3, which is fine. What I have right now is pretty good, and my straight line's not too bad either. So I've graphed the first function. Now if I want to graph the second function, y equals 1, it's been a while since we've done this, but whenever I have a y equals a single number, I want you to remember there is no slope here. We could think of this as y equals 0x plus 1. And whenever I have a slope of 0, I just get a horizontal line. Or we could also think about where all the y values are equal to 1. So I'm going to graph a horizontal line where y equals 1. And what you'll notice is in my system, because it's an absolute value function, I have 2 intersection points rather than just 1. And if I look at these coordinates, the one on the right, the intersection point, is 2, 1, and the point on the left is -4, 1. Both of these intersection points have y equals 1, and in this case, the only solution I'm really interested in are the x values. X equals -4 and x equals 2. And those are my solutions. This is how I solve a system of equations graphically when one of the equations is an absolute value function. So again, this is just part 1 of solving absolute value functions graphically. Please look forward to a second video from practice number 5. All right, good job. Get to work. Oh, and I almost forgot. Ozzy says good job too.